Hello, Mr. Thompson here. We're going to look at some examples of problems using index laws, specifically index laws 1 and 2. So I've been asked by a student to look at this problem. 12a over 3c cubed times 6a to the fourth over 4c to the fourth. When you do these problems, order of operations is important, so you need to look for brackets and things like that first. And you might think, oh, I've got exponents or these powers, these indices. So do I need to do these next? Well, not really, because you're not evaluating these indices. You're just combining them with the other letters to put them into a single unit of index form. So you're mostly actually just multiplying and dividing. There's not any adding or subtracting, so multiplying and dividing can go in pretty much any order. So if you see some dividing you want to do first, if you want to do some multiplication first, whatever sort of stands out to you first. The first thing I recommend doing is simplifying your constants, the numbers I've got in green, right? The ones, there's no indices, there's no powers on these. They're just numbers. And I look at these and I see 12 divided by 3, and I know that I can cancel those. And 12 divided by 3 is 4, so that becomes 4. And then I see 4. Then you could see, well, I've got 6 divided by 4, and that could be 3 halves. But even better than that is I see this is all multiplication. It's all going to come together eventually, and I've got a 4 here and a 4 down there. So 4 on top, 4 on bottom, they're both going to get canceled, and I don't have to replace them with anything. They're just gone. So I'm going to rewrite this to make it a little bit more clear. Okay, I'll take this 6 and just stick it out. No, I'll rewrite everything the way I have it. So a, and into we've got fractions multiplying by a fraction, right? So I do the top times the top, a times 6a to the fourth, right? And the bottom times the bottom, c cubed times c to the fourth. I leave off everything that I've already canceled. Okay. So that's my next form. Now I just have to apply a couple of index laws. So I'll make my next step, and the first thing I'm going to do is take this 6 and stick it out front. Okay, and then I've got a times a to the fourth. Those two things are going to multiply by each other, right? They have the same base, so I'm going to have an a, right? And I know that this a, just plain a, is a to the power of 1, right? A single a is a to the 1. So I'm going to have an a down here, right? And these two are going to combine to be that single a, and I'm going to take the indices, the powers, and using index law 1, that tells me that when I'm multiplying bases with indices, the same base, I'm going to add these exponents, these indices, the 1 and the 4. So 1 plus 4 is 5. Okay, and then I put my line for the fraction, and now I have c cubed times c to the fourth. Again, I'm going to have that c, and I'm going to add them using index law 1. So 3 plus 4 is 7. Okay, there's no more common bases. We've just got an a and a c, and those don't go together. We've got a 6 with no more numbers that can't be simplified. That's the answer. Okay? So that's a problem from the homework for my class right now. I'm going to do one more example, just to throw it in there. Okay, this is a pretty big one. It's got multiple letters on tops and bottoms, lots of numbers. Okay, first thing I'm going to do here is I'm going to, again, cancel some constants. Okay, it's always a good place to start. I've got 8 over 5 and 15 over 4, and what I see is that 8 and 4 can cancel, right? Okay, and when you cancel the 8 divided by 4, that's just 2, right? 8 over 4 is 2, and 15 over 5 is 3. Okay, so let me rewrite this again with the 2 and the 3 to make things a little bit easier. And now again, you could do this in lots of different ways. You can maybe simplify these k's first, and then simplify these m's, and then cancel these k's. Or you could multiply all the tops and multiply all the bottoms, and then go from there. It actually doesn't matter. Multiplying and dividing can go in either order. Okay, in this case. But what I'm going to do, the first thing I see is these two k's, right? And canceling, when you can just cancel straight up, that's the best way to go. So k and k can cancel. Okay, and the other thing I see is I've got the 2 and the 3. So I'm going to make those into a 6. Alright, and then I'll look at these k's. Okay, over here we've got k to the 4th, and we have k, which we know is k to the 1, right? And I'm going to use index law 2, so we've got k to the 4th divided by k to the 1. And when we do that, we take these exponents, these indices, and we subtract them. 4 minus 1, which is 3. Okay, and we'll do the same thing for these m's. We'll put an m here, and we've got 5 and 3, and 5 minus 3 is 2. So we got m to the 2. And then I have times, and the only thing I've got left over here, because the 3 became part of the 6, right? The 3 came over there. These k's canceled. The only thing left is just this m. Okay, so that's all I've got left hanging on from that second fraction. So we're going to combine those and make, this is the final step. So we've got our 6k cubed, and then we'll have an m, and we need to just combine these. So we'll use index law 1. We know that this m is really m to the 1, right? Plain m is m to the 1. And we'll use index law 1. We take these powers and we add them. So 1 plus 2 is 3. No more common bases, no more numbers to simplify. That's just the final answer. So that's it. All right. Good luck on the rest of your homework, and see you next time.